Hey everyone, and welcome back to The Explainer. Today, we are diving into an absolutely fascinating intersection of traditional craftsmanship and cutting-edge tech. We're looking at a really brilliant GitHub project by developer Saikaran Ramayanam that tackles a very human challenge, judging wine quality using machine learning. It's kind of wild, right? Let's see exactly how structured data can demystify a subject that usually feels, well, entirely subjective. So the crucial question we're starting with here is simply this. Can a machine actually learn to taste wine? Now, obviously, a computer doesn't have a palate. It can't exactly swirl a glass, sniff the bouquet, or pick out delicate notes of oak and cherry. But what it can do is analyze the underlying chemical properties. This project uses the famous UCI wine quality dataset, and by feeding this dataset into a machine learning algorithm, we're essentially trying to teach a computer to act as a digital sommelier. We're asking it to look at the raw chemistry and predict the exact quality rating a human expert would give it. Here's our quick roadmap for today. First up, the machine learning toolkit. Second, prepping the wine data. Third, training the random forest. And finally, tasting the results. All right, let's jump straight into section 1, the machine learning toolkit. You know, if we were making actual wine, we'd obviously need grapes, barrels, yeast, a press, the whole shebang. Well, for digital sommelier, these 5 technologies are our foundational ingredients. Python is essentially the vineyard itself. It's our core environment where everything happens. Pandas and NumPy, those are the heavy lifters used to harvest and crush all that mathematical data. Matplotlib lets us actually visualize it. And scikit-learn, well, that's the absolute powerhouse. It's the master fermentation process, providing the machine learning algorithms to turn raw data into intelligent, actionable predictions. Moving right along to section 2, prepping the wine data. Think of raw data a lot like freshly harvested, uncrushed grapes. It's messy, it's unstructured, and it desperately needs some refinement before you can turn it into anything remotely useful. So this meticulous 4-step workflow gets it ready. Step 1 is data loading, just bringing that UCI dataset into our environment. Step 2 is exploratory data analysis. Step 3 is data preprocessing, which is where things get cleaned up. We're handling missing values and scaling the numbers so no single chemical property unfairly overshadows the others. And finally, step 4, the train test split. This one is absolutely critical. You divide your data, using one chunk to teach your digital sommelier and completely hiding the rest to test them later. That way, they aren't just, memorizing the answers for the exam. Actually, I want to pause on step 2 for a second, exploratory data analysis, or EDA. Basically, this means summarizing the main characteristics of the data, usually visually. Going back to our winemaking analogy, this is that moment the winemaker walks through the vineyard, visually inspecting the grapes, checking out the soil, looking for any quirks or patterns. The developer uses EDA here to spot trends, like does a higher alcohol content generally correlate with a higher quality rating? You really have to understand the data story before you can build a model to predict its ending. Okay, section 3, training the random forest. Let's build this classifier. So the developer went with a random forest classifier. To picture this, just imagine a single decision tree as one person trying to guess a wine's quality by asking yes or no questions. Is the acidity high? Yes. Is the sugar low? No. A single tree might make a decent guess, but it's pretty prone to making mistakes. A random forest, though, is exactly what it sounds like, a massive forest of these decision trees, all working together as an ensemble. It's literally like having a panel of hundreds of different wine tasters, all making their own individual guesses and then voting on the final rating. In this specific workflow, the developer first trains what we call a baseline random forest. Think of this as our novice sommelier, making their very first kind of unrefined judgments based on initial training. But we want to make it better, right? So the developer brings in a scikit-learn technique called grid search Gravy. This searches through a predefined grid of hyperparameters, which are basically the internal settings of the random forest, like how many trees there are or how deep those trees are allowed to grow. Grid search Gravy is essentially a rigorous masterclass for our novice sommelier. It systematically tests every single possible combination of these settings, running exam after grueling exam until it finds the absolute optimal combination for accuracy. It literally fine-tunes that digital palette to perfection. The journey of improvement here is just super clear. We started with the baseline random forest. That's the algorithm straight out of the box, making good but somewhat basic predictions. Then, we applied grid search file, completely transforming it into the tuned random forest. This tuned model has been calibrated specifically for the tiny nuances of wine chemistry. It's basically the difference between someone who just read a book about wine and a master sommelier who has spent years rigorously testing their senses. And that brings us to our final section, section 4, tasting the results.
All right, we've prepped our data, trained our baseline model, and put it through a grueling hyperparameter tuning masterclass. Now it is time to pour glass and see how our digital sommelier actually performs. The first thing the developer does in this final stage is a performance comparison. Remember that train test split from earlier? Well, we now bring out that hidden test data, wines the model has never ever seen before. We ask both the baseline model and the tuned model to predict their quality. And by comparing the results, the developer mathematically proves the value of the whole workflow. The results confirm that, yep, the rigorous grid search training actually did improve the model's accuracy, proving our digital sommelier has, for sure, refined its palate.
The final step of the project is feature importance analysis. And honestly, this might just be the coolest part of the whole shebang. The random forest doesn't just spit out a final score. It actually tells us exactly how it made its decision. It ranks the features, the specific chemical attributes of the wine, based on how heavily they influence that final quality prediction. Like, does alcohol content matter more than pH levels? Does citric acid play a bigger role than residual sugar? This analysis acts as the model's actual tasting notes, giving us humans incredible insight into the unseen chemistry that defines a truly great bottle of wine.
Which leaves us with this massive, really provocative thought. We just watched a scikit-learn random forest analyze data to judge wine quality, something we usually reserve strictly for human intuition and refined taste. So if algorithms can decode the chemical drivers of something as entirely subjective as wine, what is the future of AI and other highly subjective fields? Food, beverage, perfumery, maybe even art. As we structure our data better and tune our models more finely, machines are beginning to map the very things that make us human. It is just a fascinating space to watch. Thanks so much for exploring this with me today, and I'll catch you in the next explainer.